Polynomials and evaluating expressions. So we're going to talk about inputting negatives with variables. I'm only going to take a minute on expressions because I know you've done a lot of this. But I just want to point out a couple things that students get confused on. If I say x squared and ask you to plug in x equals 3, negative 3, you must have parentheses. It's something squared, and in fact this case it's negative 3, which of course is negative 3 times negative 3, or positive 9. When you square something, it's always positive. Now, if I say negative x squared, you have to remember that this is really negative 1x squared. The coefficient is negative 1, which of course is really negative 1 times x squared. So in this case, if x is 5, it's negative 1 times 5 squared, which is negative 1 times 25, or negative 25. So if I plug in a negative, again you need those parentheses. This is negative 1 times something squared. In this case, negative 7. This is negative 1 times negative 7 squared is negative 7 times negative 7, which is positive 49, and I get negative 49. Now the reason I'm pointing this out is because students goof this up. They mix the two up. Having the parentheses means it's going to be positive because when you square, you get two negatives. Without them, this is just like that and that. This is negative 1 times 8 squared, which is negative 1 times 64, or negative 64. Whereas this is positive 64. So remember, without the parentheses, it's much different. If I say negative 9 squared, again, that's really negative 1 times 9 squared, or the opposite of 9 squared if you want. That's going to end up being negative 81. Now we're going to talk about polynomials. And I want to make sure you understand why the rules are the way they are. When you add and subtract, you add the coefficients on like terms. Coefficient, remember, is the number in front of the variable, and the powers never change. Understand why. The reason we can add like terms, it goes back to something like 7 times 7. That is 2 times 7. Yes, it's 14, but there are two 7s. And when I say x plus x, that's 2x. These two things are the same exact idea. And when I say x squared plus x squared, there are two of those x squared. Notice the x squared does not become x to the 4th. The number doesn't change. When I said 7 plus 7 is 2 times 7, it was still a 7. So if I say x is 7 plus x to the 7th, there are two of those x to the 7ths, just like there were two 7s above. And these are like terms. Now understand, what makes a term is the multiplication. Terms are separated by addition and subtraction. There are two terms here. They're exactly the same number. I have two of those numbers, 2x squared y to the 5th. I'll get students that want to pop a 2 in there, but no. This is one thing, and this is one thing, and I have two of those things. Just like 100 plus 100, maybe that's what those are above. That's 2 times 100. So let's take this and talk about why it's add the coefficients. If I say 3x plus 2x, you're used to that. That's 5x. Well, if I say 3x to the 4th plus 2x to the 4th, there are 5x to the 4th. If I say 8x squared y cubed plus 11x squared y cubed, that's 19 of those things, 19x squared y cubed. If I say negative 7 xyz minus 2xyz, I take negative 7 minus 2, which is negative 9, and that's xyz. The term never changes. The powers never change. you add the coefficients on like terms, and the powers never change when you add and subtract. Multiplying. You multiply the coefficients and add the exponents on like bases. Let me just point out, when you say 3 times x, you're all going to go, oh, Mr. Caldwell, that's 3x. And you are correct. But you really didn't do anything. It's still 3 times x. There's multiplication between those, remember. You drop the dot. Just like when you say x times y, it's xy. It's still x times y. Now, they don't have to be like terms to multiply, because again, it comes back to the idea that these two are really just the same thing. We're writing it without the dot. But exponents come into play when you multiply. We know that 7 times 7 is 7 squared, and x times x is the same idea. It's x squared. X times x times x, there are 3 of them. That's x cubed. And right below here, there are 5 of those x's. That's x to the 5th. Now be aware what you're doing is you're adding the exponents. If there is no exponent on a number or a variable, it's always a 1. Anything to the first power is itself. And notice that 1 plus 1 made 2, and here there were 3, and below at the bottom there were 5. You add the exponents on the same base. The x is the base, and the 5 is the exponent. 3x times 6x, well, I can multiply in any order. There's times between everything here. I'm going to take 3 times 6 and get 18. X times x, that's x to the first and x to the first. That's x to the second. 5x squared times 4x cubed. Well, again, I'll take 5 times 4 because I can multiply in any order. That's 20. I've got x times x here, and I've got 3 of them here. They're going to be 5 altogether, x to the 5th. And again, I'm adding my exponents. 3 and 2 make 5. Notice that 8 times negative 3 is negative 24. Always put the negative in front. Sometimes we'll get students that put it between things, and then it's a subtraction. Not what you want here. There's 2 x's here, x times x multiplied. There are 4 here multiplied. That means there's 6 multiplied altogether. This is y. You heard me say a bit ago, if there's no power, there's a 1. Y to the first times y cubed, there's 1 and 3. That makes 4. Negative 9 times 6, that's negative 54. Negative always goes in front. X to the 7th times x to the 8th, 7 and 8. There are 15 x's multiplied. I'm adding the powers on like bases. Y to the 5th times y to the 10th. Well, that's y to the 15th. 10 and 5. When you multiply the coefficients, the numbers in front, and you add the exponents on like bases. Parentheses to a power, or a power to a power. Now the reason I'm emphasizing these 3 is students get them mixed up. Because here, you're going to take the coefficient inside the parentheses to the power and multiply the exponents. Well, understand, look at x squared cubed. This is x squared cubed, which is x squared times x squared times x squared. Notice that there's a 1 in front of all these. 1 times 1 times 1 is 1. And x squared times x squared times x squared, there are 1, 2, 3, 4, 5, 6 of those. That's x to the 6th. And we don't usually put the 1 in front, but there is 1 there. 1x to the 6th. Notice it didn't become 3x to the 6th. I get students that, oh, you multiply the exponents, and that's true. That's the shortcut. 3 times 2 is 6. But you don't, that 1 in front is not an exponent. It's 1 cubed, which is 1. Same thing below. There's a 1 in front. It's 1 squared, which is 1. Well, x to the 5th squared is x to the 5th times x to the 5th. And there's a 1 in front of both of those. That is 1 x to the 10th. And again, 2 times 5 is 10. So 3, I'll take the 3 and I'll square it. 3 squared is 9, not 6, but 9. 3 times 3. X to the 4th squared, well, there's 4 and 4. That, of course, makes 8 because I'm multiplying. You add your powers, but shortcut, 4 times 2 is 8. X to the 8th. 5 cubed, 5 times 5 times 5 is 125. I got 4, 4, and 4. Shortcut, multiply, that's x to the 12th. Let's look at these examples. 3 to the 4th, 3 times 3 times 3 4 times, I believe that's 81. X to the 5th is to the 4th power. Shortcut, multiply your exponents, x to the 20th. Y squared to the 4th power, well, that would be y to the 8th. Next example, 4 squared, 4 times 4, not 8, but 16. 4 times 4 is 16. Again, multiply your exponents. X cubed squared is x to the 6th. Y to the 8th squared is y to the 16th. Last one, x to the 20th cube, well, that's x to the 60th. Y to the 15th cube, 3 times 15 is 45. The reason, again, I emphasize these is because there's 3 separate situations and students get these mixed up. Because when you add, the powers never change. When you multiply, you add your powers. And when you add parentheses in a power or a power to a power, you multiply your exponents. So you have to keep it straight. Are you adding? Because the powers never change. Are you multiplying? You add your powers. You have a power on a power, you multiply your powers. Negative exponents get thrown in here in the mix. And you might have seen these in algebra, but we need to review because you're going to see quite a few of these throughout the year. And let's just point a couple things. Think of it this way. The base, when you see a negative exponent, is on the wrong side of the fraction line. What you do is you move the base to the other position, either above or below, and you make that exponent positive. Move it to the other side of that line. When you see negative exponent, you should think reciprocal. What's going to happen is it's going to move the other side of the line, and you're going to take the exponent and make it positive. Look at the first example, 5 to the negative 2nd. Well, this is over 1. Anything can be over 1 because anything divided by 1 is itself. I'm going to move it to the other side of the line. It'd be 1 over, got to put something above. And this is 1 over 5 squared, which is 1 over 25. 2 to the negative 3rd. Reciprocal, move it to the other position. That's 1 over 2 to the 3rd, or 1 over 8. Notice that negative power does not mean the answer is negative. It means reciprocal. Your base is on the wrong side of the fraction line. Move it to the other side. Change the sign. X to the negative 4th. Well, it's just 1 over x to the 4th. And you're done. We look at the last one here. 1 over y to the 5th. That negative power means it's on the wrong side of the fraction line. So this becomes y to the 5th over 1, which is y to the 5th. In this case, they're both on the wrong side of the fraction line. The y to the negative 3rd will go above, x to the negative 2nd will go below, and they both become positive powers now. In this next one, you're going to move the negative 3 to the bottom, and you're going to move that x to the negative 4th above. So that becomes x to the 4th above, y to the negative 3rd goes below, becomes y to the 3rd. We can simplify this. We're multiplying. We add our powers, x to the 6th and y to the 5th. Ooh, this one's kind of weird. Everything is to a negative power. Now, you could apply the power on a power rule. You don't really have to here, but I'll just show you. This would be x to the negative 6th, and this would be y to the negative 9th. Power on a power, you multiply your exponents. 3 times 3 is 9, negative 9. And 2 times negative 3 is negative 6. And then you move position. Y to the 9th goes above. Change this to the other side of the fraction line. Make it positive. X to the 6 below. Now notice what happened is the y's went above and the x is below. And yeah, I multiplied my exponents. Very quickly here, I'd like you to kind of understand why it works the way it does. Look at x to the 5th times x to the negative 2nd. You're multiplying, and when you multiply, you add your powers. So we know that 5 plus negative 2 is 3. That's x cubed. Remember what we said. That means that when you see a negative power, it means it's on the wrong side of the fraction line. X to the negative second is 1 over x to the second. Now I can put this thing over 1 and multiply. I'll multiply straight across. X to the fifth times 1. Hey, that's x to the fifth. 1 times x squared is x squared. Well, look, I have x's above and below. I can cancel. I'll cancel 2 here, and they're all gone. I'm left with a 1. I'll cancel 2 here, and there are going to be 3 left, and that's x cubed. Really what's going on when you say 5 plus negative 2 is 3 is, in effect, that negative 2 is canceling out 2 of those positives, and that's why we have 3 left. Cancel, cancel. Quick review. With polynomials, students get these 3 mixed up. When you add, the powers never change. You add the coefficients. Notice there's 2 things there. Add the coefficients, powers never change. Multiplying, again, 2 things. You multiply the coefficients and you add the exponents on like bases. Parentheses to a power, that's a power to a power. Take the coefficient to the power and multiply your exponents. And then remember, negative exponents, when you see that, the negative means it's on the wrong side of the fraction line. Move it to the other side and change it to a positive exponent. The negative exponent means reciprocal.